PaOneStop is a set of online tools designed to help farmers meet state regulatory requirements. It currently consists of a farm mapping module and an erosion and sedimentation control planning module. Two additional modules are currently under development, a manure management planning module and a manure transfer module. You can visit the website at www.paonestop.org. Several state agricultural regulations require farm maps. Some of those include nutrient management plans, manure management plans, erosion and sedimentation control plans, and nutrient balance sheets, which are used for manure transfers. In addition, farmers can also utilize maps for general purposes around their farm. Farm maps can be very difficult to produce for users that aren't trained in modern mapping technologies. The requirements for maps can vary significantly depending upon the regulations. The PaOneStop farm mapping module provides an easy-to-use interface that allows a user to produce high-quality farm maps free for any farm in Pennsylvania. Let's take a look at how it works. The first step in farm mapping is to create a new farm. Each farm is given a name and a street address to identify the farm location. GPS coordinates can also be used if available. The initial location is based upon geocoding of the address. The user interface can be used to modify the location using the aerial imagery. The next step in mapping a farm is to draw and outline the fields found on the farm. Various tools are provided to allow you to zoom into the imagery so you can see and identify the field boundaries better. Each field is outlined using your cursor by simply clicking around the boundary or the perimeter of the field. If there are holes in the field, such as a pond or water body, those can be removed at a later date. After outlining the field, identification labels can be assigned and the field needs to be saved. Once the field is saved, the acreage is automatically calculated for the field. Minor adjustments can be made. Here you're looking at a field being adjusted so that it aligns better with the aerial imagery. After each edit, the field must be resaved so that acreages can be recalculated. Soils data are also retrieved for each field. Here you're looking at the distribution of soils spatially across the field. We also provide tabular data showing you the relative distribution and acreages of each individual soil map unit. We also provide several other base maps, topographic base maps, or LiDAR-derived slope base maps. Most mapping is done on aerial imagery. Each field is saved within a comprehensive database for the farm. Those can be accessed, retrieved, edited, and resaved as many times as needed. The next step in mapping a farm is to draw farm features. These are items other than fields, things such as wells, sinkholes, manure storage pits, animal heavy use areas, etc. Features can be represented as polygons, lines, or points. Here we're going to simulate the drawing of a water well. We simply click on the map, identify the kind of feature it is, provide a label, and save it. For each map feature drawn, a manure setback can also be identified. These are areas where manure cannot be applied, and they vary depending upon the regulations. Here we're specifying a manure setback distance of 100 feet. These setbacks can be created as needed. A second kind of feature we're going to illustrate is a stream location, which we're going to draw as a line. So we simply click along the center line of that stream. When we get to the end of it, we're going to double click and identify it as the type of feature it is and save it. The manure setback can be delineated, or if the stream has a permanent vegetative buffer, a 35-foot permanent vegetative buffer can also be identified. Each feature, and there can be as many as you want, is saved within the farm comprehensive database, and you can retrieve it and edit them the same way you edit fields. Here we're looking at multiple features mapped within a single field. The area of the feature itself may be subtracted from the field acreage, and the area of manure setback is also calculated for each field. Hardcopy maps can be made within PaOneStop. The system allows you to make adjustments to labels. You can add and delete labels. You can make adjustments to fields and features. And you can hide individual fields or features on any particular map you want. If you do not want a certain field or feature to show on your map, you can simply click on a little checkbox to say that you don't want that to show on your map. The field or feature is still present in the database, and you can turn it back on as you need it. You can also adjust the base map, air photo or topo, which you think you want to have for your map. There's a simple button to print a map. You can give it titles to your map and print one map that shows the boundaries of the fields predominantly, and all the other features that you mapped, manure setbacks included. This also includes a legend and a scale bar and a north arrow that should meet any mapping requirements. It also includes calculated acreages for field and the acreages of fields that are suitable for manure application. A second map focuses on soils within the field, and we provide a breakdown of the soil distribution within each field, each map unit within each field, and we also give you the breakdown of the entire farm. Here's an example of a field boundary map drawn upon a topographic base. You can make as many maps as you want. We do not save any of the published maps. The second module in PaOneStop is the Ag E&S Planning module. This module is designed to help farmers develop Ag E&S plans for their farms. Written Ag E&S plans are required for all agricultural plowing and tilling activities greater than 5,000 square feet. This is according to DEP Chapter 102 requirements. This also includes no-till agriculture. Ag E&S plans are also required for nutrient management plans according to Act 38. Let's take a look at some of the details of an Ag E&S plan. One of the requirements, and most difficult requirement, is that the plan must limit soil loss from erosion to a soil loss tolerance value, a T value, over the crop rotation. What this means is that for each field, based upon the management practices of that field, the topography, the soil conditions, and other properties, climatic conditions, soil loss needs to be calculated, and that soil loss needs to then be compared to a tolerable soil loss. Tolerable soil losses are determined by the USDA NRCS for each soil type in the country. The plan must also include maps showing locations of various features. This could all be done in the mapping module of PaOneStop. The plan also must include a description of BMPs for animal heavy use area practices and procedures. Other details like tillage system, crop management, crop rotation needs to be entered into the plan. Additional BMPs may also be required in a plan for any field that's within 100 feet of a stream, depending upon the crop cover or residue conditions of that field. The plan must also include an implementation schedule. The plan needs to be available for review and inspection at the farm. It needs not be submitted to anyone, but it needs to be available for inspection. PaOneStop provides several tools to help make this planning process easier for farmers. The very first thing it does, and most importantly, is it calculates soil loss for each field based upon the current management practices in place for that field. Soil losses under current management practices can then be compared to the soil loss tolerance values. If the soil loss under current management is less than the T value or equal to the T value, no changes may be needed for that farm. If soil loss values are higher, significantly higher than the T values, then PaOneStop allows the user to develop and evaluate alternative management systems in order to reduce soil loss to acceptable levels. The system also allows the user to evaluate the impact of various cropping systems and conservation practices and what their impact is on soil loss. The interface used to calculate soil loss for a field in PaOneStop is shown here. All information needed to calculate a soil loss for a field is entered here, and soil loss values are retrieved here. This interface consists of multiple sections that describe the characteristics of the field, conservation practices that may be in place for that field, the crop rotation, multi-year crop rotation that may be used, and also the ability to change management practices and save them in different scenarios, as well as the calculation of soil loss and its comparison to the t-value. We'll now take a closer look at some of the sections within this interface. Field characteristics consist primarily of soil and topographic information. Fields can contain more than one soil, and a representative soil needs to be selected for each field. Steepness of slope, slope length, and the percentage of rock fragments contained in a field also need to be determined. Some of this information is determined from high-resolution LiDAR topographic data provided for Pennsylvania. Default values are selected for all of these parameters and entered into PaOneStop. Users have the ability to override these parameters if they feel it is necessary. Conservation practices include contouring, strip cropping, buffer strips, contour strips, diversions, and terraces. PaOneStop allows the user to select multiple types of conservation practices and specify characteristics of those practices. Crop rotation information allows for the entry of multi-year crop rotations, with more than one crop being planted in a given year. A crop selector tool allows easy entry and selection of crops, tillage practices, planting dates, yields, and manure applications. All of these parameters impact soil loss, and we provide a user interface that is very simple to use. The calculation of soil loss is simply a click of a button. The interface provides the calculated soil loss in tons per acre per year, an average value over the multi-year crop rotation, and that number is then compared against the t-value, or the allowable soil loss. If the soil loss is acceptable, or less than or equal to the t-value, then no changes in management are necessary for this field. If the soil loss is too high, alternative management scenarios can be created and evaluated, and the user can create as many alternative scenarios as are necessary. Once acceptable soil losses are determined for each field, an Ag-E&S plan can be printed describing details of all the information entered within PaOneStop. Use of PaOneStop is increasing rapidly. As of May 2016, over 4,000 users had conducted mapping on 13,000 farms, mapping over 100,000 fields and 60,000 farm features. A look at a close-up within central Pennsylvania shows extensive mapping within agricultural valleys. Periodic hands-on training sessions are conducted throughout Pennsylvania. Stay tuned to the website for locations of these training sessions. Financial support for PaOneStop is provided by Penn State, Pennsylvania State Conservation Commission, Pennsylvania Department of Environmental Protection, and the Pennsylvania Department of Agriculture. Technical support is provided by USDA NRCS. Thanks for visiting PaOneStop.